All right, I guess we can start now. But I would like to first use the first 5 minutes for us to just have a small chat about how your ALX experience has been going. And I hope some of us has met up with the cutoff mark. So anyone can share with us their own experience or what they think about the program. While they wait some extra 5 minutes, then I will stop accepting people to join the meeting. No, you can unmute yourself. No need of using the chat. Just unmute yourself and speak. Yeah, what's up? Uh, or 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 one semicolon. All right. Anybody? Any other person? Okay. Good afternoon. Just go on. Okay. Okay. I will answer that question. Okay. 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 I get someone else. Please. I will answer that your question. No. Okay. Go on. Okay. 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 Okay, I get your points. I will answer that too. All right, someone else, please. You can unmute yourself. No need to raise up your hand. We have 1 minute left. Yeah, sure. Go on. Okay. Okay. I guess we are up now. It's 12:15 in my place, though. So let me just mute all microphones. All right, so let me first answer some stuff you guys said. Let me just I'll be very honest as usual and realistic to you. It's not possible to get to do all the old tasks within 24 hours. Okay, and as ALX is doing their own things every day, they will bring in the same kind of weird, stressful projects. So it's actually hard to keep up with that pace of saying you want to do try the tax on your own, like try to want to do it on your own without using any dubs or stuff like that. It's actually impossible. Let me just put that word. It's actually impossible. Okay. So my own advice as regards to that aspect, and just so you know, let me just quickly say something concerning what Ade Time said about you. Maybe when you've used the GitHub Expo now, the GitHub sheets, then you won't feel like wanting to return back. Exactly the word weird. Okay, so okay, so like I was saying, so the aspect of you using the cheats and not being able to come back to it to get to understand it, you're actually making things worse for yourself. That's what it means. I'll just let you know that one. Because all each project as you progress, they are kind of linked with themselves. So there is no way you must have to at least, even if okay, probably even if you don't get to read most of those tasks back or the question, at least understand that concept. Don't leave that, don't just drop that concept one place. Probably that is why my channel is here, just for you guys to at least get to understand the concepts. And obviously, it's very clear that Python is much easier than C programming. I feel the reason they chose to start with C is just to make us feel tough, for us to be tough in our thinking and everything. C has its own advantage, and also it's just like a big plus in your CV or your resume. Okay. So in data structures, C is very good in data structures compared to Python. You can't allocate memory in C. I mean, you can't allocate memory in Python just as the way you allocate memory in C programming. Probably later you get to discover that anyways. So they are actually, both of them are still important, just so you know. I think Julian made mention of one thing about a girl like that who got to work at Tesla all because of her knowledge in C programming. So let's just not play around with the C. Me sef, I know even during my time, I know how C was very stressful. My own plan was that I always try to read ahead of each task so that I will feel overwhelmed. And I always make sure I get to understand every concept. So don't skip any concept, please. So I'll just say in general or in summary, just focus. If you feel C is hard for you, fine, no problem. But just focus on knowing the concepts. You might get to Python and prefer Python to C. You understand? So, but don't feel as if you don't need C. Just get that aspect right. Don't act as if or feel as if you don't need C. You will still need C along the line. Even in Sprint 2, they usually mix C and Python together. Safe. It's kind of stupid though. Okay, but so just keep that at the back of your mind. So just focus on the concept and flow with each of the tasks. So understanding each topics, each concept. So when you have the time, you can get to review them. And I think that's all about that. Son of man. All right, I guess let's just start now. Okay. Don't before I start these pointers, don't feel scared about these pointers. You understand? It's actually simple. It's just for you to reason. Okay, so I will try my best to try to make it as basic as possible. Please, I won't be probably later I will allow you to ask questions, but for now, I guess we are running out of time and we are using data here. Okay, so we have to be considerate also. So we are going to start pointers now and just be open-minded, like just feel calm and just listening, pay attention to what I will say. Like you will surely understand it. Anyway, I believe I have this experience of teaching, so I will surely break it down to you that you understand. So don't feel as if it will be hard. Okay, motivation don't choke. Yeah, I don't choke. All right, so let's just start something now. So let me share my screen. Um, okay, so share the entire screen. Okay, I choose to believe everyone can see my screen now. Okay, so next week I'm going to do pointers, and I think the pointers is they broke it down into two. So the first one is like just like introduction, like play or pointers, while the other one is the annoying part of pointers, whereby it leads to pointers connected to another pointer, kind of annoying. So if you can understand the normal pointers, all this other one will be the same for you to understand. Okay. So let's just quickly start something. Oh, I just remember something. I forgot to open my code blocks. Sorry. All right, so let's just start. So understanding, I mean, instead, and please just get a note. Just get a note or a jotter. There's a way you can just write in your own format, in your own way that you get to understand some certain things. Don't just be listening, you get work with a jotter. All right, so let me just quickly start. So instead of assigning values directly to variables, like you know that whenever we are, I don't know if you must have noticed that whenever we want to declare a variable, probably if I want to write something like this is a variable and I want to give it something, and if you just do it this way and just print the, oh sorry, print f, um you just want to print the stuff there. Oh sorry, all this want to start joining, they don't follow rules and regulation. I'm not accepting anybody again. um so I think this is it now. Okay, so if you want to print this kind of stuff, you know it will show you an error, and the error issue, it will tell you that you have not declared the variable. Now that is where the aspect of the whole concept of pointers, address, and contents all comes into play. So instead of assigning values directly to variables, you can indirectly manipulate a variable by creating a variable called pointer. So which contain memory address of another variable. So this is why pointers are also called address variables. So you can actually call pointers address variables. So but it's popularly known as pointers. Okay. So pointers or address variable. So either name you choose to call it. So let's start with differentiating or talking more about what address is versus what content is. So let's start with the aspect of address. I guess when a variable is declared, like whenever we declare int x or char y or float z. So whenever we declare a variable, a piece of unused memory is stored. Okay, that's why if you just write x is equal to 2, then you want to print 2, it won't just work. That you have to tell you that you have not declared it. So we declaring, what we are doing is that we are creating a memory that we want to store the value of what we want to put in that x. So if I'm saying int x, that means that int is an integer, right? And I remember saying integer have a size of, the size of integer is 4 bytes. So once you do int x, it will go to the memory and store 4 bytes of memory for int x, for x in particular. So whatever content you put inside your x will be what we store inside that memory. You get, so just keep put memory in your mind like your ROM, just like your system hard disk, hard drive, like your memory card, something like that. So it will need to allocate some kind of memories. Once you say int x, and you know integer has 4 bytes, they store 4 bytes of memory. So it will store 4 bytes of memory somewhere. So that's the purpose of this declaration that we are doing. So after we've stored that empty, non-used memory, then once you now put x is equal to 4, then it's that 4 that will enter inside here. I believe that is already is understandable. Okay, so when a variable is declared, a piece of unused memory will be reserved for the variable, and the unique address to the memory be associated with the name of that variable. So we get to understand that later. Okay, so the address associated to the variable, that's the address where the memory lives. Okay, just imagine the memory is a person. The person is living in US. Okay, so that's the address of where the memory is. Okay, so that's the address. So when I'm talking about address, we can choose to call this same address as left value. So it can also be called left value. So whenever you're using like left value, they are also talking about address. Okay, so it can be interchanged. So when the variable is assigned a value, the value is stored into the reserved memory as the content. Okay, so that content is what we call the right value, or you can call it content, you can call it right value. Now, in summary, what we are saying now in general is that Now I want to type in something, I want to code something. So I first create the house, or probably let me put it in a layman way. Okay, so this man want, I want, should I use this man? Um, okay, I want to buy something for someone. Okay, okay, someone is stranded, person needs to live somewhere. So I say, okay, for you to, I can give you an address for you to stay. So I'll first book a memory for you to stay in. So this int x, I've declared a memory somewhere for you to stay in. And that memory also have an address. Okay, so the x and the int is stored somewhere, but nobody is living there yet. So now, if I say x is equal to 7, that means 7 is like the person now living inside the memory where that integer is, where that 4 bytes of memory is. Okay, so now when we're talking about the right value and the left value, the right value is this x, the address of where this x is stored. I mean the address, yeah, that's the address, okay. While the right value is the value, the contents of this x. So that means this 7 is what we mean by the contents or the right value. While this the place where our x is stored is the address. Okay, so the left value, the right value. So the left value is the address, the place where the int x is stored in the memory. While the 7 is the contents that is being placed or assigned inside that memory. You understand now? So that is just it about that. So note that when your C program is being compiled, so that's why if you notice whenever you want to run a program, you have to make sure you have declared that program or else it won't run. All right. So now let's talk about the address of operator. So there's something called, uh, sorry, voila. Okay, so something called the address of operator, the address of operator, which is described or labeled as this and. Okay, so this and, so the address of operator is, this is the symbol for it, this and sign. All right. So what does it do? So it's just for us to see or visualize the address for ourselves. So in C programming, we even, I mean, the C language even provides you with an operator, which is this address of operator, in case you want to view the left value. That's in case you want to see the address for yourself. Okay, we're talking about address. So if you want to really see that it is true, the address is there, you want to see the value of the address, then you will need to use this and sign operator, which means, for example, if I want to see the address of this X here now, what I would just need to do, I will just, it will just be like some, I can choose to, can use several ways anyways. So I can just say y is equal to and x. So if you print y, as if you print y to tell you the address of this x, okay? Or you can even just put the address of the x directly without needing to, like something like this, print f. Yeah, just so you know, this time around we're using the format specifier of preset p. So for pointers, okay. So something like this. So you can use this function to find the address, to show you the address. So let's assume in this case the address here is 255. So this is the address where where this integer memory is being stored. Okay, why the 7 is the contents stored inside that X, inside that address. So for us to visualize the name of that, and just so you know, the address varies, it depends on your operating system. Okay, a Mac operating system will show another address. All those addresses, they are picked at random. It's just so you know, they are picked at random in the big memory, okay, in the stack. So they are picked at random. So that's just what it is. So it actually varies. It varies according to machine. A Linux laptop will show another address. Windows laptop can show another address. Even 32 bits and 64 bits Windows operating system will show different address. All right, just so you know. So just focus on whatever address your own machine choose to show you. All right. So now let's move to the aspect of how to declare pointers. So declaring pointers. So for us to declare pointer, the general form or I say syntax of declaring pointers, we just say the data type, then we use an asterisk, then put the pointer's name. Very, very important. This format is very, very important in terms of declaring a pointer. So just the same way you are declaring your X, your char, is it char or car, anyone, and your floats. So the same way we are going to declare pointers. So your data type, so if your pointer is an integer, I put the int there, but always make sure you put this asterisk. That asterisk is a note, is the identification, is the clear identification that this is a pointer you are declaring. Okay. And for that 2-bit machine or that 2-bit system, pointers size, that's the data type size for pointers for 32 bits is 4 bytes. For 64 bits, which is what most of us are using now Windows, so for 64 bits is 8 bytes. Okay, just so you know. So pointer stores 8 bytes of memory. All right, so that's just the aspect of declaring it. Um, okay, so we'll just get to see some examples anyway. So we'll get to see examples of what this whole pointers talk we've been talking about really mean. But before that, let me just define pointers again to you. Just know that pointers is something that stores values of, let me not say values, they store or they have two addresses, one at the right hand side, one at the left hand side. Okay, so just if they're in the middle, they have one address at the right hand side where the value is usually placed, and another one in the left hand side. That's the address where the pointer name gongon itself, let me not say gongon, as is stored. Okay, so let's start with coding, real coding now as regards to this concept. So it will make more sense to everyone. Okay, so this was the last one we did the other day. This one made me out sore throat that night. All right. So let's see a good example as regards this. Um, all right, so let's, as usual, include standard stdio.h. Then we have our main function. Okay, let me add the int main. Okay, yeah. So as usual, we always have the return zero at the end. Okay, good. So let's start off with the aspect of um, talking about the address and the right value, left value. So I want to create three variables now. So one of them will be a character, one will be an integer, one will be a float. Okay, so I will say int x, let me create them separately like this. So int x float y, and we have character c. Okay, now let me give them some values. So C, since the character, let me give it, remember characters are enclosed in a single quotation mark. Okay, so let me not talk much about this. I want to assume everybody understand this already. Okay, so we have our x, giving it a normal value as it's an integer. We have our y is a float, so let me just give it anything, 1, 2, 3, 4, 5. Okay, points. So to make it a float, that's a decimal number. You can actually put all this stuff in a single, as in the separate line. So I just chose to put everything in a single line because of space. I don't want to waste space here. Okay, so next up, I think there's one more. Okay, so next up, I will like to let's print and visualize each of these variables one by one. So let's start with the C variable, the first one. So let's check for its address so we can see the address of it. So I'll say the address of C. Let me use the equal to sign. So remember I said for pointers, when you want to check for address or if you want to check pointers, you have to use this format specifier that is %p. So %p is the format specifier for calling pointers. All right, just like we have %d, we have %c. Okay, so we want to check the address of C. And we want to check the contents of C. So for the aspect of the content is just like all this normal stuff we've been doing, like all this A7, so normal. So since this is A, that means I will just check for normal percent C, which is the character. All right, so I just want to see the character of A. So that is not an issue. So as usual, I like creating that new line just to give some space. So remember how to use your printf. So I'm going to call the variables that represent each of these percent P and percent C accordingly. So for the first one, percent C. So since percent P rather. So since this is an address, and I made mention of how to label or call an address. So we are using the address of operator to call an address, which is this and sign. So I'm going to put and the name of the variable there. So the name of the variable here is C. Okay, that means I'm going to put here the and C. Then the next one is our percent %C, which I'll still just call the normal variable of C. All right, so let's view this and see what's up. Okay, yeah, I've got that semicolon. So let's build this. Okay, so we can visualize here that this is the address of C. Yeah, it is this long. So it can be long. It can change. Your machine can show you something else. So it doesn't really matter. Okay. So this is the address where C is stored. All right. Now this is the content, what is inside that address. So this is the person living inside that house. So A is the man living inside that house of that address. Okay. So just, I believe this is very understandable now. So let's just repeat this stuff. Let's repeat this step for the other two. So let me just copy this just to save time. Just copy, paste. So I'll just make some small modifications. So next one we're going to do for x, which is for our integer. So integer, I will leave it as percent %d. Remember percent %d for integer, decimal. All right, so that means I'm going to write the name of the variable. So since we're dealing with x, I'll write x here. That's the address of the x, then the normal x variable. Okay, so again, I will do it for the floats. For the floats, we have the y. So y is a float, so I'm going to say f. Then this will be y. Then this would be y. I guess we are good. So let's print this again. All right, so looking at it, we have address of each of them and their content, which is obviously what is showing here. Although you've noticed some issues with the floats, it's just like no float lies doing I2 Sabi, so we can just force it to show exactly the way it is here by using what do I call that stuff again? Precision. Yeah, I mean I remember one of my lecturers has that stuff. Yeah, so using some kind of precision method to do that. So I'll say 5.2. Okay, so that point 2 is just to limit the decimal place value. Okay, so I think it looks better now like this. So these are, you can see the address and the contents. So all these things we've been doing since Hello World, since we started C, we've actually first been declaring the variable. We've first been creating a memory inside that we don't know, which we just know now. So we've been storing an unused memory. Yeah. So after that unused memory, once we assign anything, then that memory will then won't will convert from being unused to used. So used in the sense that this A will be stored inside the memory, or 7 will be stored inside that memory, then whatever will be stored inside this the other memory. All right. So that's just what we've been doing. And the right hand side is the content, like I said. So that means what I mean by that is that, sorry, go back. So the right hand side is the content, which is this A. So it's the contents, while the left side is the address. So that's like the address of C, kind of like address of C like this, but we don't write it this way. We'll just put it like that in the back of your mind. So that's why we're using all these addresses here. Right, so the left value and the right value. So I hope this is already explanatory for everyone. So now let's move forward as talking about the aspect of pointers. Okay, let me just pity this one. They are even lucky. It was even by luck I get to click this stuff. I wanted to click my notebook here. Okay, so let's move to the aspect of pointers. And so for a pointer, we said this is the format for declaring a pointer. So we say, what does pointer really do? So it's just screenshot. I can't use English. I can't use English or explanation, oral explanation to explain it. Let me just use code to explain it. So let me just go back to my code blocks again. Okay, so it's best that way. Let me erase this. Okay, so I guess we all at least understand the aspect of address and content. So address and contents done and dusted. Yay! Okay, so now let's move to the aspect of pointers. Pointers, so we can get to understand what it means and how to go about it. So let's start with the C again. So I'm starting with the first variable again, C. So watch this now. Watch what I will do. So remember we're dealing with pointers. I want to deal with pointers now. So I'm going to declare pointer just like the way I'm declaring these normal ones here. So I'll go back here. Since I want to test it for everything, so I'll have to declare it for everything. But I'll give pointers its own different name, just so you know. So I'll give it a different name. So I will say, so this is int, so I don't need to write integer again. So I can just go ahead to write pointer. That's remember that asterisk. That's the symbol to notify that this is a pointer. So this is the variable name I want to give it is ptr. Mind you can use any name. You can use Lexis, any name you want. You can even use letters. All right. So let me just give it something you can all relate with. That's ptr. So you notice it's a pointer. So I'll name it ptr and ptr underscore x. Okay. So for the float aspect, float pointer, I'll say ptr underscore y. Then for the character asterisk ptr underscore c. So I've declared my pointers as normal as we'll be declaring. I've not done any magic here. Everything is still normal declaration that we all know, right? So now next step for us to do is then to see the application of how this pointer works. So for the application part now, let's focus on this C. So if you can get this C part well, the rest will be easy because I'll just like repetition I'll be doing. Okay. So let's focus on this C now. Now I want to create a pointer that points to C. All right. So if I say ptrc, remember this is just a name, like a variable name, which is the variable name here, ptrc. Okay, so that's the variable name that I use in declaring it. And just so you know, even this asterisk, just don't put it in your mind and say these two are together. You can even put a space here. So it's not as if you want to declare it now, or you can just always want to be packing it together. There's a time you get to understand how to do it whenever it comes together or what it means. So for now, just know that you can just call the normal name without yet including that asterisk. You get all right. So I'm just calling the normal name, which is ptr underscore c. And so this time around, like I said the other time in my definition of pointers, so pointer points. So let me look for a much explanatory definition. So a pointer to a pointer is a form of like, let me not say pointer to, I'm even making things worse. Okay, it's just something that has its own memory and its content. More the content is the right hand side. So the content takes its own address. Like a pointer has its own address, just like every variable. C has its own address, X has its own address, Y has its own address. The same thing, ptr-c, it has its own address at the left side, which is this side. So it has its own address inside. Okay. Now, in the right side, which is this value side. So the value side of this is A, which is our content. Our 7 is our content. 123.45 is our content. So now the contents here, when it comes to pointers, must also be an address again. So that means we have address in the left place and we have address in the right place. That is just the definition of pointers. So that means since I'm dealing with C, I'm going to write the address of C. Remember, to write the address of C is just to use the and sign. So the and sign C takes it that way. Okay, so as if we are storing the address of C inside this ptr C variable. All right, so now let's visualize this now. Just saying we will visualize this upon. Okay, so for us to do that, I'm going to then use my printf. Okay, so just the same way we wrote this, that's how I want to write this. So I'm going to say PTR underscore C. I want to see the address of this one. So I'm going to use percent P. Then I want to see the content also of this one. Now, the content of this one is an address, right? So whenever you want to call or refer to any address, you will also need to still use percent %p as format specifier. If you notice, we didn't use percent %p here because this is just like a normal value, character 7, 1, 2, 3, normal. But this one, let us not say it is abnormal, but it is an address, okay? So, and you want to call an address, you're going to use the format specifier, which is percent %p. All right. So just so you know. So as usual, your new line, then we're going to place each of them accordingly. Okay, so the first address, we're talking about the address of PTR underscore C, right? So I'm just going to write, okay, the address. So as usual, just the same way we called the address of C here. We said and C. So the same way we're going to call the address of PTR on C. So I'll say and PTR underscore C. So that will it will replace this percentage P format specifier. Then the next one is the content, right? So for the content, it's just the same way I just call the normal C variable, just the way you're using your point F. So the normal C variable to receive the content. So I'll call the normal variable here, which is PTR underscore C. So that's PTR underscore C. So as usual, end with your semicolon. So let's print this and first see how this one goes. Okay. Um, just let me quickly do something. Okay. All right. So notice we have PTR underscores. So we have the point. So this is the address of the pointer. This is the content of the pointer. I can see the content here is also an address. And we're dealing with C, right? The content, you can look at this part now. We have and C here, the address of C. Now go back to this first point F we did here. Where is the address? The address is this P, this first P here, which is looking at this our output. We have 615E17. Notice it's the same thing that is here also, 615E17. So we're recalling that address inside this our pointer portion. I hope you understand now. So that's just the same. So I believe, get to look at it well. Look at it well, though. I believe you understand it before you say I'm rushing. So look at it well, compare it well. So the first thing, we have our ANSI. ANSI, the AND sign is the sign for calling an address. And we already know our C address as 615E17, which we've already done in the first part. So I put that address to store inside this new variable which I call PTRC. PTRC will surely have its own different variables, so you can see its own name is different. Variable address is different. Every address here are different, all right? So the content here is different now because whenever you are dealing with pointers store content of address. So you can't just put ordinary C here or whatever. You have to put an address in the right value, all right? So I hope you understand this. So I'm going to repeat these concepts now for the remaining two. That means I will copy this two, copy, paste. So let me just make the necessary modifications. So this is X, this is X, X, and X. So the next one for the Y, okay, Y, 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 Y. Okay, so let's print again. Okay, so looking at this now, the X, remember the X will also take an address. So let's look at the address of X, 615E1C. It seems that is also in this our pointer here. So the address of Y, looking at our address of Y here, 61FEOC is the same address we stored inside our pointer here for pointer Y. Okay, so I believe that is well explained. Let me push it like this. Is there a way you can get to see both of them at the same time? Well, it's not possible, sadly. So I just believe everyone gets this aspect. So let's just, in short, before I move on, Before I move on, let me just take a question. So at least, before I jump back too much things, let me just take one or two questions. Um, okay. Ab Adetimehin, you'll be the first. So let me just turn on your mic. Okay, now you can unmute yourself. Ade, no, they put okay. The put try is just for create. I just created a new line. I didn't want. I just created a space. Okay, just like a. It's not like I did anything special there. I just expect you guys understand what I did. All right. All right. So any other question? Okay. Do the best. The best. I can see you raising up your hand. Okay. Okay. Percentage X. Okay, probably it may be possible because even the normal percentage D we've been using, you can also use percentage I and to work the same way for you. So maybe it can be possible, sure. All right, so any other person, okay, dollar per must so no address is just a memory is just yeah. No, those zero is the is your okay, just put it that those zero is the number of your street, the place you are living. Okay, just put it that way. So don't think like just put like it's your address, it's your home address. So irrespective of how it's being numbered or how it's being written, doesn't really matter to you. You understand? So every system have their own format of writing it. Okay, it seems she has. Okay, so okay, let me see the queue. I think there's one more. Okay, Emmanuel Edwin, unmute yourself, please, Emmanuel. Okay, you've lowered your hand. Okay, no more question. Okay? Cordon, Cordon, you can unmute yourself and ask your question. Yeah, okay. I will soon show you guys why this pointer is important. You'll get to see it after this call. So it's like the next step to understand the necessity of it. 'Cause it might be like, why was the need of the pointer when I can just use normal variable and get the thing done the same way. So don't worry, you get to understand why pointers are necessary. So it's just more of like manipulation anyway. So I think there's no more question. I'm seeing the same repeated person, so I'm not sure if they're still raising up their hand again. Or let me just go on. Let me just look at the chat a bit. Yeah, I'm recording and Anderson. Okay, then you have one question. Okay, please ask. no. This okay. I guess you have to mute yourself now. This stuff, sorry, I ain't create any user defined or any special thing. Look at my, it's just a normal STDIO. And well, this question sure just remind me of something. You would have noticed in your head, so you'll be seeing something like underscore picture, maybe underscore print f or all those. I'm not call it nonsense, but to me it's kind of annoying and nonsense because you don't need all those things. Like ALX are the stuff that create those stuff for themselves. You understand? It's not safe, is something you will need in the real life sense. Just like now, do you see me putting underscore here? No, you don't need it. So ALS are just forcing us to use their own created special thing. You understand? Just the same way Betty came to be. See desktop icon. Just the same way Betty came to be. So it's not as if those whenever you're seeing those underscore picture, just put in your mind that it's still the same picture that you know of. Okay, nothing special. Okay, so all the stuff I'm doing here, I didn't do any special thing here. If you write all the same thing in your own code blocks or in your own editor, you will get the same output I'm getting here. The only difference you may see there is the difference in the address, and I've talked about why it will be different because every machine has its own different address, and this address is actually stored randomly in the memory. All right, so that's just it. So I didn't do any special thing. You can test it yourself later after the call. Okay, so I guess we've talked a lot. So let's quickly proceed. Okay, so I think the next thing I'll be talking about is something called the reference. Well, we've already seen it. So the reference operator, which is it means this asterisk. So those asterisks we've been seeing, the pointer stuff we've been talking about. So this asterisk is just called the reference operator, or you can also call it the indirect operator. The indirect, the reason they chose that other name indirect is because if you want to manipulate something, let's say for example now we have a variable called x and we assign x as 4. So instead of maybe if tomorrow I say I want to change my variable value, I don't want it to be 4 again, I want it to be 10. So instead of me going to the x directly to change it as 4, that's when I will need pointer. I think I've now answered one of that other guy's question now. So instead of me going back to that variable to use my hand and type it and delete it, use backspace and put something as 4, I can just use pointer in any angle, anywhere I find myself in, and it will be updated there automatically. All right. So that's what we are going to see very soon, which I think that will be like one of the next example we'll be doing just to understand that. So, but before that, so this is the reference operator, or you can call it the indirect operator. All right. Um, so just as the previous example, likewise, given an integer variable, if we have an integer variable of, if we have integer variable, okay, okay, we are going to declare as usual. So we have integer variable x, and we assign x, maybe x has 1, 2, 3, 4. Okay, that's 1, 2, 3, 4. Then if we have a pointer, for example, oh, okay. Sorry, let me quickly do something. Okay, good. All right. So as usual, we have a normal, we have normal integer variable, and we declare the integer x. Then we have the normal value 1, 2, 3, 4. So we can also declare a pointer, maybe something like ptr. Short. Let me use something else. Whatever. So this is my pointer. Then I come to this place, I write whatever, sorry, let me use, I come to I write whatever is equal to my address of x. Okay, that means it's taking the address of where this our integer here is stored in. And since, mind you, I declared the normal x variable and I also declared the pointer variable, which is called whatever, right? So if I want to manipulate, so instead of me going here now, if I said maybe tomorrow morning, I said, oh, I need to change this to 120. So instead of me going back or looking for the variable to change it to 120 or change it to raw like this, I can leave it as this. I can leave it there and come down here and change it directly by using the pointer. So I'll now put asterisk, which is the reference operator, indirect operator. So I'm indirectly entering inside my pointer and giving it a new value 120. Then if I print x, no, right now I'm using the wrong print syntax, but just get the point that if I'm once I now print this x, the value of x will now change to 120. It will no longer be this 123 that you are seeing here. So that's just what this pointer is all about. Okay, I think there are some stages in the back end that it will be hard to be going back to go and find something to change it. So that's why you just need to use a pointer at some point. You understand? A pointer at some point. Very funny. Okay, so we're going to see a quick example of how this comes into play. And there's also something we call the null pointer. The null pointer. So what does this do? This is just simply a pointer that is pointing to zero. Pointer instead of it to be pointing to an address, it's pointing to zero. So this is an example of a null pointer. Okay, so null pointer. So that's just what it means. Just it's not as if you really need to know it, just for knowing sake. Okay, so let's see a quick example that explains all this story I've been saying. Mm, okay, so let's go to our code blocks. So I'm going to remove this now. I want to believe we've digested this, we've eaten it. Even if you've not eaten this, if you've not eaten this morning, at least you get this one this morning. So and your belly is full. So we'll get rid of all of this. Okay, and start a new coding. So this time around, we want to look at how to change values of pointer from another angle, just like what I said or what I've explained here. So we want to see it work real live. So to work in our Kuro eye. All right, so the first thing, as usual, I'm going to say character. I want to work with the character. You can use integer, I can use anything, okay? So I just want, so I want to work with the character. So let's work with the same character. See, I don't want to repeat myself with the integer and the float stuff. So let's just focus on one character. The same thing applies to the rest. So as usual, it also have its own pointer, which I just choose to use PTR underscore C. Mind is not by default to use PTR underscore C. I just choose to use it so that everybody can get to flow that this is a pointer. I don't use just a random word. You can use a random word, and this is not an inbuilt function or a by force thing to write this sentence. I think that is one of the questions that other guy was asking. So if you can use any name, it will still work for you. Um, so and again, let me just say something again. Even if you don't declare your own stuff like this, you can just declare it like this. It's still the same thing, no difference. Oh, sorry, not integer. Both of them are a character, so it's still the same thing. All right. So let me just, even if you even put a space here, it's still the same thing. But if I think the other one looks better to look. I mean, looks better. Okay, so let's proceed. So I'm going to assign a value. So let's use our normal a again. It can be anything. Okay, so let's repeat what we did the other time for the aspect of printing the address for C and the content of C. So as usual, just put your point F. So I want to put the address of C address. So the name with pointer. So percent %p contents percent C. Remember that the content is just the normal stuff. Okay, so since we're dealing with character, that's why we have to use percent %c. So that's the usual format specifier for that. I don't need to explain that part. I believe everybody already know that one. Then, so the address, I'll give it the unsigned and C, while the content, I'll give it normal C, my semicolon. Let's just check that we are on track. Okay, so we are on track. We have the address, we have the contents, which is A. Okay, now let's call a pointer. So I'm to call this pointer here. So I'll say PTRC. I'll first call it normally. So I choose to call it normally first. Then give it and C. Alright, so that's the first thing. First call it normally, yeah, as if it's a normal variable, PTRC, normal. But ensure that you give the right value and right hand side value as an address. Okay, so this is an address here, and C is an address. Okay, I don't think I have any need to explain that part. So now let's visualize this, just so we visualize it the other time. So I'll say print F. So I want to look for the address and the content of this. So PTRC address, give it percent %P. Then the content is also an address. So again, percent %P. Then the new line. Then we have the first one is the address of the normal variable here, which is PTRC. So I'm going to write and PTR underscore C. And the last one is the normal contents. Yeah, since it's the normal content, I just call the normal name of the variable, just like the way C, you call the normal C. Okay, so I'm going to call the normal PTRC without putting and this time around. So PTR underscore C. Okay, so let's build and run this to confirm we are on track. Good, so we are on track. So the address of C, we're doing the address of C as 61F1F. So we place it inside the PTRC also, which is what is also here, the same thing here. Okay, I believe everyone understand this part well. So now moving forward. Now watch this. Now I want to print what this stuff means. Though I already know what it means, okay? So I want us to visualize what you think might be the answer when if we are to print something like asterisk PTRC. That's when the reference operator comes into play, right? Which is the indirect operator. So I'm going to say printf asterisk. Mind you, don't need to put this asterisk. Okay, I hope I'm not confusing you guys. You know that all these sentences here, these blue parts, you can put anything there, just like writing a story. You understand? Nothing special. The only thing special here is just these format specifiers. Okay. So the same thing here. All these things are just normal write-up, normal English text. The only difference is just this different specifier. This percent P, percent P. Those are the important things there. So me writing as the repeat here doesn't mean I've written anything special. It's just normal text I'm writing. All right. I'm just trying to differentiate it from all these words I'm putting here, just so we can flow well. Okay. So we have PTRC, and I want to take the address. This is the address. Okay, no, I want us to visualize what will be the output. Okay, so let me just use this kind of notation. So, like arrow sign, what will it bring out? Something like that. So, I'm going to write percent %C here because I already know or I expect to know what it will bring out. So, what will this percent %C here represent? It will represent the actual PTR underscore C. Let me put this part in a separate line. So let me explain this again. So we have the printf. This is just a normal text, just for us to visualize what is going on inside this printf. So the major focus here is what does asterisk ptr underscore c hold. So what does it hold? So it actually holds the value of this c. Let me explain how it works. This is how it works. Yeah. So this is how it works. So we have asterisk PTR underscore C, right? Now, it is a pointer, which means, we have PTRC normally. This is PTRC normally, okay? So it first see, in short, I'll remove the asterisk first. So it first check what does PTRC as, or what is the value of PTRC? And PTRC is what? It is and C, which is what we've seen here. So PTRC, in short, let me not use this comment so we're able to see it well. So PTRC, it holds and C. Okay, now if I'm to put a pointer at the front of this PTRC, what it now changes, what it means now is that I'm entering inside the address of C. I want to find the criminal that is living inside that house, the hacker that is inside that house that have hacked my money. So I'm entering inside the address inside that C to find that scapegoat. And the scapegoat inside that C is as is A, because A is what is inside the C. That's what is assigned to C. So that's what the whole asterisk stuff is doing. So if I'm to print this now, we should see that this would be give us A. So let me run this code. You can see here now asterisk ptr dash C enters inside the address. First of all, you check this place. Okay, then say, okay, this is the value, this is the address P that is saved inside this pointer. Then I want to enter inside that address of P. So I enter inside this address of P and check what is inside that P. And what is living inside that P is A. Okay, so that A is the person that is living inside. So that's what it means here. That means since I can get this A through this means, that means I can modify this A here without needing to touch this place at all by just changing it from directly from this angle here. I believe you're already getting it now already, right? Which means I can choose to then say asterisk ptr c is equal to b. Now I've modified this c, just so you know. I have modified this c. Let's test it. Okay, let's test it. So if I say print percent c C. Now notice I'm printing C. I didn't print PTRC or whatever. Okay, just for us to be sure that if it will give us the same A or to give us this modified B that has entered inside like through the pointer. Let's say results. Okay, so let me run this and let's see for ourselves. So what's the result? As you can see now, the result here is B. Mind you, look at here, it is C. I put a variable C, which means I'm expecting the normal A. Instead of it to come out, what comes out? It is B, which means the pointer has modified what C is holding. So that's the advantage of pointer. That's the necessity of we using pointers. So we enter inside the address where the pointer is being stored. This is the address where it's being stored. This is the first thing, the address. Then inside the address, enter inside to fish out the criminal. And the criminal here is letter A. Let me not say letter A for Alex. Okay, so that's just how it works. I believe this is well understood now. So that's just the essence of we doing these pointers. Um, okay, so I think that is just all you need to know at this aspect here. Is there any need for questions? Or probably let me just rewrite. Let me make it look nicer a bit. Let me just make it look nicer a bit. So I'll just say print f. So say want to check the address of PTRC. I think have we done that? Okay, we've done that the address of PTRC and the contents of PTRC. Okay, no need of that. Okay, we've done this other. Okay, probably you can just copy and paste then. So let me just copy this. Let me copy this other one. Sorry, you are a late comer. I can't accept you inside the meeting. Wait till it's done. So last one, let me just add an extra printf that says, now C, remember we've done, this is the address for C, the initial part of C, right? Now this is now the new updated version now. So C, let's check the address. Well, I think the address will still be the same. It's not as if we change anything in the address. So whatever address that is here will still be the same address that will be here. So percent P, then the contents of C. So I guess is the content that will change, right? Because the content here was A, so we modified it to B. So I'm expecting to see B here. So new line. So what are we printing again? So we want to print PTRC, right? So PT. So we want to print the same C again. So and C, just for us to be sure that it is modified, and the normal C, then the semicolon. So just as if I rewrite this stuff again, just for us to test it to see if any changes is there. So let me build and run. Okay, so let's quickly look at it. So this is the first print line, which is the first one we're seeing here. So look at the last one and let's compare it to the last one. So the address, like I said, the address for C will still remain the way it is. Nothing changed. But let's looking at the content here was A, which was the A here. Now the last part, the content here is B, which is the B here. So that B was done through this pointer stuff. Okay, so that's just it. So the pointer entered inside A and changed, modified what A means to B. So that's the transition that happened there. So that is it about that aspect. So I think let me do one more example as regard this. So pointing to the same level. Well, if that one is yeah, what I want to even do is not really that much necessary anyways. So just know that we can also create multiple pointers that points to this same memory. Okay. Like let me just try to do something like PTR D. I'm just putting a random stuff, okay? So PTR D. And I can just say, okay, well, since I have PTR D here, we have PTR C here. Let me just put PTR D. I can assign it as PTR C. So that means whatever that is inside PTR C, the same thing equalize it with PTR D. That means anything I'm doing, even if I put D here, it will still modify this C for me. You understand? So this is just it's not good. I don't know if it's really useful for you to know. Just know that multiple you can use multiple pointers to still point to the same thing. Okay. So, but I don't really see the need for it though. All right. So just understand this concept of pointers. So let me just do a quick roundup again for the last time before I take question. So we have the standard stdio.h is enough to run all of this. We have the main function. We have the declaration. Let me get rid of this one. So first of all, we have the character C. We have the pointer. Pointer. Don't forget this has to notify that this is the pointer. If you don't put this stuff, this is just like a normal variable. Until when you put that the reference operator, that's going to say, okay, this is a pointer. No problem. So for this aspect here, C, so normal declaration of C, normal, this one is not, it's just simple. So we call the address, we call the contents using the AND operator, the address AND operator, okay? So then whenever you want to deal with pointer, so after you've declared it like this, call the normal, write the normal name first. So the normal name is ptr underscore C, which is ptr underscore C here, equal to whatever address you want to store inside. So since we have only one variable here, I want to use C. So put the and C. Okay, so that's the address I'm assigned to this. Don't forget, pointer store address in the right value. And it has its own internal address since it's a variable, because all variables have their own address and memory. So it has its own inner address, so which is the address that we printed out here. Then the and C is what will be printed out here, the contents, which is and C. That's the address of C. Okay. So remember to print the normal address of your variable. You have to put your AND operator, just like put the AND operator in this C part. Okay. So you print the normal variable name to get the value. So this is the value of this is the value of this A. So you put your normal C. This one you put the normal PTRC. So then we'll call this function asterisk ptr underscore c. So what this asterisk ptr underscore c does, it will first step, it will move inside this place, check for the value of this. So since you see the value of this is an address of C, that is and C. So it will enter inside that address, inside the house by force, to badge in inside the apartment and look for the person that is inside. And the person that is inside this our C is what? A. So that is A is inside there. So now it's modified that C. Instead of it being A, I change it to B. So that means anytime I print C, instead of C to give me A, it won't give me A anymore. It will only give me B. Okay, so it will only give me B. But mind you, if you print it before this pointer, like for example, if I print it here, um, percent C, new line. I just want to create a big space between it. So present. So if you print it before calling this pointer, it will still be the normal C that will come out, which is A. So just so you know, you can see that's the A. So the A is still there. So if you want to be sure it has changed, you have to call this stuff under or after you've done the stuff. You've called this pointer below. That is below here. So if you run this, it should give us B. So you can see now we have B here. Okay. I didn't clean this one. So this is the first one that is the A. Why it is under, then it changed to B. Okay, so we have A, we have B. So I think that is well explained. So let's go back for questions. Um, okay, Oluwatosin. Okay, you can unmute yourself now to ask your question. Okay, okay, do best. Ask your question. Okay, okay, let me see. Let me just tell you one thing about this election. They are just making things harder than it seems. You understand? Just like that main dot H, that thing is not really necessary. Like everything is already in standard STL. Why would I need to be doing main dot H? The reason they are using those main dot H is just so that it will complement those underscore points, F underscore put, child, those nonsense that adding there. So that's why they are forcing that main dot H to get that, use that header file. You understand? So just you want just focus on knowing the major thing, the major C. You understand? All those other one that ALS are doing, just put it as just do it for the doing sake, just to fulfill righteousness. Since that's what they need for the checker to run, or the checker will not check you correctly. You understand? So what I would just also say is that that's why I say you need to understand this concept. So even if you pass your tax and just get away with the 24-hour deadline, then come back, then relax, balance with your cool mind, then review those questions and look at those answers. Like once you look at them well, it will make more sense to you. And yeah, I agree with you that the questions in ALS is not detailed enough to understand what to do. And I think they said they don't realize it. But since we can't do anything about it, we just have to bear. So just understand, just once you look at at least it's a different thing. You getting to look at the answers now, get to understand it. And if you don't know the concept at all, that means you are totally lost. Totally. You understand? So you are still in the right track if you choose to want to understand those concepts first. So that's it about that. So I did see me. Okay, okay, you want to teach us, like teach us. Okay. No, no, I get what you are saying now. It's a good thing now. So just for you to be sure that you get what okay, but just be fast because people are using data. Okay. Yes, sir. Okay. The third one is just this part here. I can choose to erase this. Like it's not really okay. Hmm. Yeah, change the value for C. Yeah, the address, content. Yeah, so that's just basically it. Okay, I think that's how do we balance doing the basics and index witchcraft? Ask maybe we need to ask the village people about the aspect of the witchcraft. They will know their own solution. Okay. Exactly. Yes. No. Exactly. So yeah, that's why I just say just focus on the normal real function, not the LX stuff. Because you won't be using sandbox forever now. So you will surely use your ah now you're asking me to create my own software engineering program now. Or let's what I was say I second that. Uh, that one is that is an okay, I think I think you can see some anything exactly. I get you. I get you. Okay, I understand. Anyways, what you artists do, it will just it's just as if you ask for some kind of it will have to require some kind of like compensation in a way. Like I can't be doing that kind of stuff for free. Like it's an extra work and I just even this one I'm even doing is like a work for me. When no, what is my mind? I have something to do with Python. I want to build some kind of project now in Python. I have to create squeeze this time to make sure I get to this point and stuff because of the point that is coming next week. So I'm trying to cope with several things. So me sacrificing my time creating questions and creating something that looks relatable it's like another extra work. So I don't really know. Unless if there's a special group we get to create, maybe a special WhatsApp group, or special people, or something like that. You understand? So if that is what you feel, probably okay, I will suggest it in a WhatsApp group, okay, and I will make it I will explain it better, sha. Like anyone that's who are interested in something like this, yeah, so they should just join. And you pay a fine, something will compensate me. Okay, so I can't be stressing myself just like that. I have to drink small pure water, small now. I have to buy data, data especially, or airtime, so I can call my mommy now. Let me check on my mommy. All right, all right. So let's just move on. I think remember today we wanted to talk about pointers, arrays, and strings. Okay, so we've actually basically talked well on as regards someone is not there, Auntie. As regards to pointers. Okay, let me just okay, yeah. Olawole, Olawole Banji. Okay, yeah, yeah. Since it's not manual, different exactly. No, no, well, no, no, no. Okay, okay. You are talking. Okay, okay, okay. Okay, Banji, we've read you. What I'll just say is that there is still an added knowledge in terms of getting a task to do. Let me just let you know that because if you just watch this video and you just type this thing, you'll be relaxed and you'll be limited. So that's why what those other people said initially, they are still right. Because you need some kind of random, trickish, another way to convert questions for you to reason. You have to stretch your brain to really think. So if you limit yourself with my own examples and not try other things or try to see, you are not doing well, or that's what it means. Because they can come in different angles. So that is why that one is still necessary. Okay. So, or if this one works for you, if you think, or Mola, or if it works for you, you can stick that way. Okay. But I think generally it doesn't really make sense. Even me, say, when I'm able to learn Python, I have to make sure I check different questions too, just so I can flow well with it. And to make me research more, 'cause I will not see new thing that I didn't know. I have to now use Google. Now find new function, I'll find new something, stuff like that. So that is why this tax is one. Just that ALS is making it extra hard, and at the same time, probably making you do more research and doing more things, and the stress. So, anyways, that's just about that part. So, like I wanted to say, so I planned on doing pointers, arrays, and strings. So, as it is going now, we won't have time to touch arrays and strings, but I will touch pointers very well. So, I would like to close with pointers. Probably tomorrow we'll create another live session like this again. I pray I have the strength. Okay, so probably tomorrow we'll get to create another session. So, I would like to end with the last aspect of this whole pointer stuff. So that's what we'll be looking at next. So I think the aspects involve pointer to another pointer. What we've been doing here, if you've noticed, is just a single pointer, like single pointer. There are cases whereby you have to put points, use a pointer to enter another pointer, to enter another pointer, to enter another pointer. Now that one na die. So that aspect, I think that will be the second ALX tax after the first initial pointers. So the next ALX tax is pointers to pointers. So let me just quickly look at that aspect. So let me just so that we know that anything concern pointer, like I'm done with pointers since you understand. So probably tomorrow we'll get to look at the aspect of strings and arrays. Okay. So let's move on. Let's move on. So I think that's all for question and answer session. Let me mute everybody again. Muted. Okay, so we're in the final lap now. Now, this final lap kind of looks tricky, so I want everyone to pay attention very, very closely. So that's why you need to ensure you digest this stuff very well. Look at it with one corner eye again. Just use one last corner eye to look at it. I'll count 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ta-da! It is removed. Um, okay. So now I want to advance further as if you notice even the topic I wrote here is pointers to pointers to pointers to pointers to pointers to pointers. So that's who is this one? Just put here. Of hopefully she will even get where to want to do now because we're even in the hard stage. So now pointers to pointers. So a pointer to a pointer is a form of multiple indirection. Okay, so multiple indirection or a chain of pointers. So pointing to pointing, we're pointing to different things at the same time. So normally a pointer contains the address of a variable, since we already know, right? So when we define a pointer to a pointer, the first pointer contains the address of the second pointer, which points to the location that contains the actual value. In the real sense, what we're trying to say here, let me use my notes here. Let me scroll down. Okay, let's take for example, we have pointer. Oh, I want to make it big. So we have pointer, pointer, pointer. Okay, no, not pointer, pointer. Let me say this is variable. Now, what we've done so far is this session. This is what we have done previously, like just now. So we use pointer to enter inside the variable to get whatever value that is inside that variable. Okay, to get the whatever value that is inside the variable. Now, what we want to do is like now we can add another pointer here Now this other pointer, its own value will be stored inside, as in its own. Okay, you know what? This other pointer here. Let me name it as let me use the normal pointer C that we've been doing. And this time around, since it is a second pointer, so since it is second pointer, I'm going to use to the what do you call that stuff? The referencing. Okay, so I'm going to use two asterisk. That's the normal way of notifying it, though, just so you know. So that's how you have to do it. Since it is two pointers, like you're pointing to point something, something. So the normally is the normal pointer. So you have to have a double pointer. Okay, so this is second pointer. Now this second pointer will point inside this pointer here. So that means it will take the address. It will take the address of this other pointer. Okay, let me name this one as pointer one. This one as pointer two. And this particular one too is on its own a pointer too, like just a normal single pointer that we've been doing here as ptr c1, which this one on its own takes a normal address of c. Okay, and then we know that our c can have its own normal value as whatever. Okay, since it's a character, let me just give it a character stuff. So now you can see now, so this pointer, this one now is double pointer. This one is best to as double pointer. So it first points inside this, just like the way we explained that. Look at the same in analogy. So this pointer here, it enter inside this address and fish out the scapegoat that is inside this address of PTR. And the scapegoat that is inside this address of PTR is actually C, as is actually this address of C. That's the scapegoat. But now since we have that's the first pointer that has done its own work. Let me do it this way. So that okay, we have two pointers. So the first pointer, the first asterisk, fish out what is inside this address, what is living inside, which is address C. So address C is actually living inside here. So it will print out address of C. Now, if you put this second pointer again, that means you want to point further. So that means inside this address C, to point again, what's inside this address C again, inside here. So what is inside our, which is A. So to enter inside and to fish out the value of A, which is the value here. So that's what this double pointer is doing. So that means you can also modify it. You can also modify A, that is this A here, by using this double pointer. I can just say this instead of A, I can change it to B like this, which is still within after this. So we have to do arrangement have to be in this accordingly. So we have the first asterisk, we have the second asterisk. So if there's a third one, same thing, there'll be a third asterisk for a third pointer. So that is just how we'll be going like that. So I believe you understand this explanation well. So let's see a real example of it now. I would have liked to use my, what do you call that stuff? Is it, is it joystick or pen tab? Whereby I can easily draw something or sketch something that you'll be seeing on my screen, but it's not with me here. I left it at home. So probably later when you get to a caution, I would have forgotten it. All right, so just try to understand it through my words of explanation, because I would have preferred to use my hand to write something or draw a sketch of a memory. Okay, so now let's see a very practical example of what I have been saying so far. Okay, um, which should I start with first as a good example? Okay, let me start with this example. So we have main, if I say we have an integer which has a variable, okay, so let me name the variable as x. So we've declared the variable, which means we've declared an unused memory, right? Then we also have a pointer, ptr. So that's a pointer. I can choose to put underscore x, but since I'm dealing with only x, so no need of me putting the underscore, let me just leave it as ptr. Okay. Then I want to declare another pointer to pointer as double pointer. So now we have two pointers. We have the single pointers, we have the double pointers, you can have triple, you can have quadruple, you can have 1,000,000 pointers. So now we want to assign a value for x. So I'm giving x, since it's an integer, so I'm giving it a number as, let me say 2000 or 200. All right, so let's work with how the first pointer works. So the first pointer as usual, which is this first one here, PTR. So we just say PTR equal to the address of X as usual. Remember pointer holds address, okay? So it holds address, so the address of X. So if we are to use the, okay, for this double, oh, I'm supposed to use another new name. So let me use PP. So pointers, so something like that. So I supposed to use a new name for the double pointer. It's not the same name. Okay, so the first pointer, which is PTR, as usual, to take the address of something. So it's taking the address of X. So let's do the same thing for the PPTR. So the PPTR also will take an address. Pointers always take address. So address of what? Of the normal single pointer. Okay, so you take the address of the normal single pointer. Now, now let me just explain something here. Um, let's assume the address of X is 200. Address of X is 200. No, not 200. This can be okay. 112. Let's assume the address of PTR is 221. That means now the address of PTR 221 is what is being stored inside this place. That's the value of this PPTR. And even this PPTR too has its own address. All right, so which you can point it to, just like we've tested the other previous examples. Okay. So now let's just see how each of them works or how to test each of the pointers. So if I say, let me say print, there's a new line here. So print F. Well, it seems I've been conversant with this printf now than using print from Python. Okay, so if I have percent %d new line, so I'm just pointing the normal value. I just want to see the values, okay? So normal values of x on num, this should give me 200, right? So let's just check this 200. So that's for the x value, right? Let me write um, value. Okay, so that's the value for that. Let me build this again. So you can see the value for x is 200 as we all expected, right? So now let's look at this. Now, remember when I said that when you now do something like p asterisk ptr something, it means that you are entering inside this x, inside this address to fish out 200, which means you now change the 200 to 300, right? That means even if I didn't do that, maybe I don't want to change it. It means this asterisk ptr is just, as in it standing alone like this, is still referring to 200. That's what it means. Okay. So it's enter inside the X and it's taking 200, but I'm not giving it anything. I didn't change it. If I want to change the value, that's when I'll put equal to whatever. I didn't put anything. So this PTR asterisk is still referring to this same 100. It enter inside the X and fish out this 100. This 100. Okay. So I'm just going to write it here like print F. So that means it's still the value. So it's still a value. So value is equal to, and I think 200 is an integer, so percent %d. Then we're going to write asterisk ptr, which is this still the same thing as this 200. So let's print this and see it for ourselves. You can see it's still 200. Okay, so it enters inside the X address and fish out the same 200. We didn't declare any, we didn't give it any new value, so that's why it still remains as 200. So it's as if X is the same thing as asterisk ptr. That's what it means here. So it seems as if X is equal to the normal asterisk ptr. Now the last part, pptr. So we have double pointer. So just like the way it is double pointer. So first point first inside is address. So what is inside this address? So enter inside the address, the scapegoat that's inside the address. That's the value of what is inside this address is our x. So that's the first pointing you've done. So address x is the first pointing. Then we point again. So once we point again, that means we're entering inside this address x. then check what is the value, which is what 200. Okay, that means what it means now is asterisk pptr as it is that is still normal 200. So we entered from one pointer, entered to another pointer, then we entered to a variable. So that's what this double pointer did. So the first one we enter to, remember this PTR on its own is a pointer. So we enter to the first pointer, which has a value of an address X. So, and X is the address. Then the last point, remember we're dealing with double pointer. So we've done the first move. Then the second move, we enter inside this X again to get the value of what's inside the address of X, which is what 200. So that's why this is 200. So we can print this, print F, value, percent D, which 200 is a decimal number. Okay, so asterisk pptr semicolon. Okay, let me get rid of this before it brings some kind of error. So we should get all the same thing. So you can see they are all the same thing. I mean, you can see that there are different ways you can still modify it. So even if you have been working, you have many pointers, you can still modify a pointer too. You understand? So you can still modify a pointer also. So that means it's also equal to the double pointer PTR. Now we can also modify it. Now, okay, so we can choose to also modify this our X. So now watch this. If I write asterisk pptr is equal to 300, that means I'm entering inside this place and I'm changing this place to 300. Okay, so it will affect everything. Yeah, since the print is below. Let's check that. Oh, what am I doing? Oh, sorry. That should be, wait, we have the pointer. Okay, I've given it the address. Okay, sorry. To do that, we're supposed to use a bracket. So bracket, that's the first pointer movement, the second pointer movement. So it's not as if you just write the PP as in the double pointer just like that, like together to bring that error. So we need to use a bracket like to separate the stages of the movement. So it will first move as a normal pointer. So whatever value, then it's run the other last pointer. So let's see this aspect. Let's see if it will bring some kind of error. So let me even check the expected. Oh, I didn't put semicolon. You can see one of the annoying thing about C. I didn't put semicolon here. Thank God for the debugging errors. That's how I'll be stuck here and be looking for what's the issue again. Okay, so let's build again. So you can see it has modified everything to 300. Okay, so that's just how to use the double pointer, just like the single pointer too. But if we run only for the single pointer, it won't modify the last double pointer, or will it? Let me see. I don't think I've tried that before. I see single pointer. Okay, it won't bring some weird. Uh, it didn't reflect at all. Okay, sorry, I'm using the wrong user. I'm using the wrong variable name. So I think this is the double pointer. So let's try it again. Okay, it still affected everything because obviously everything has still points to this thing. So since the first initial pointer here has changed what this means, it means this third one, which everything has to equal to themselves, to also get the same value. All right, so let's just quickly see one more example as per this whole stuff. So just quickly, I don't know, screenshot or snap this. So let's just see a quick example again. Now, what I want to focus on now this time around is to get to see how to maybe change values again or view their addresses, just like we've been viewing it the other time, just so we won't get confused. Okay, so let me just click on that one. Something like int x equal to 5. So I'm declaring a very, okay, let me not declare it this way. So x equal to 5. Let me give that space. So we have x given as 5. So I need a pointer also. So I'll just say integer p as my pointer. I will need a double pointer also. So pointer. Let me use q this time around. Okay, so we have a normal variable, we have one pointer, we have a double pointer. Good. So now I've declared x. Let me just put this stuff like this, just so it won't take unnecessary space from the screen. Even aside this, I can just choose to use a comma. Okay, it looks much better this way since everything is an integer. All right, so x is equal to 5. Then, as usual, this is our first p pointer. We take an address, right? So to take the address of our address of x. Okay, and now let's modify what x is here. So that means if I say pointer p is equal to 6, what does that mean? It means that our x has been modified to 6, right? So no need of me pointing this. I believe we all get this aspect. All right, so we have modified the value of our x here. Well, you know what? Let me just point it just to fulfill your righteousness for after hearing stories. So percent d new line x. So let's print x variable. Want to see what this x will give us. To give us the same 5 or to give us 6 as the updated one. So as you can see, it gives us 6. So we are on track. Okay, so let me get rid of it. All right, now we've done the single pointer. Now let's do for the double pointer. So with double pointer, we're going to call the normal name of the pointer. So it is just like the way we did the normal name of this p. Now this p is the pointer here. So first call the normal pointer and the address. Same way we are going to do for this q. Call the normal q. So as you write the name, then write the address of it storing another pointer. Since it's a double pointer, so it's storing its own right value will be an address of the pointer itself also. So that's why we're using p here. Okay. So after that, then we'll do the double asterisk stuff for double pointers. Should we modify? Um, do we need to? Okay, you know what? Let's try that. Let's just try it. Let me modify. So we have double pointer as okay. We already declared it. Okay, let me just use semicolon here. Let me create a third pointer. Let me create a third one. So we have asterisk r. Okay, now this is a third one. So we're still going to follow the same approach. So we're going to take the normal r variable is equal to the address of the preceding pointer, which is this p. Okay, so that is and q rather and q. Okay, and just for to avoid confusion, so third pointer. This one is the second pointer. This one is the modified value. Okay, which is actually a pointer also. Okay, all right, now let's test several printing now. This is the fun part. Okay, so let's see what will give us. What do you think will happen when we print asterisk p? So I will write it like this: percent d new line asterisk p. Just pause and think in your mind that what do you think will come out once we print this value? What do you think will come out? Think about it for the next 5 seconds. 1, 2, 3, 4, 5. Okay, so looking at it here, what should come out is actually obvious. Are people raising up? Okay, raising up. No need to raise up your hand, please. Let me just be two first. Okay, so what should come out here obviously should be our 6 because we've already modified it, we've given it a new value here as 6. Okay, so that's why this one now has been updated as 6. As mean there was nothing here. This would have given us 5. Okay, But since we modified the value here, giving it a new assignment as 6, so calling this will give us 6. So 6 should be our output in this part. So you can see this is 6. So let's see another test question. Percent D, new line, percent Q. So what do you think would be the answer to this? Think about it in your mind. So what do you think would be the answer to this? 5 seconds. 1, 2, 3, 4, 5. Okay, now let me walk you through the process. Now, since we have asterisk Q here, and this is the Q, well, probably let me space it. Let me just space them so we won't get confused with the cursor explanation. Okay, so since this is asterisk Q and Q, this is Q, right? Now, what this asterisk does as usual, asterisk Q, it will go inside. Sorry, wait. Okay, so since this is Q, it will enter inside and it's a pointer, right? So it go to Q. This is the address of, and the value of what Q holds is the address of P. So to enter inside P to see what is inside P. Okay, so to enter inside P to confirm what is really inside P. So now entering inside P, this is P here. What is inside P? Address of X. So that means it is address of X that's going to print out here. Address of X. That's what is going to print out in this part. Again, let me say it again. We have Q here, right? Q is actually a double pointer, right? So this is the first Q. So the Q enters this address to check the value of itself. Then it enter inside that address to find what is the answer. What is it point to? What is that address point to? Who is the person living inside this address? That's the first asterisk. So it's checked inside P. This is the same P up here. So the P, what is it holding? It's holding an address. So to stop here, that's the first pointer move. So it moved once like that. All right. Just the same way this our P moved. So our P here, what happened in this our P again? The P check itself, check its variable, its value, which is P. The value of it is address of X. So it enters inside the address and check what's inside the address. Okay. And what's inside the address is actually 6. 6, it should have been 5, but since we have modified it here, so it will change to 6. So the same process for the Q. So the Q check for itself. What is it holding? It's holding an address. So it will enter inside that address to check what is that address holding to. So what is this P holding? The P is holding address again, address of X. So to print out address of X. So let's confirm that. So I'm going to run this now. Okay, so you can see. So this 6 is the first one that we did here. This other one is actually the address of it here. So that's the address. I think since it's an address, I think I'm supposed to use percent P since we're dealing with address. So let me build this again. Good. Yeah. So this is what I'm expecting to see. So you can, or probably let's confirm if it is true that this is the address of X. So you can still confirm that if you want us to confirm that. So what will I do? Let me do it at the top here. So I'll say print, I want to confirm the address of X. So that is percent P for address. Let me use new line, new line, new line. I need good spacing. So address of X. So let's compare if indeed this pointer will give us exactly the same thing that we are hoping to see. Tada! They are still the same thing. So that means we are correct. Okay, so that's what it prints out for us. So let me get rid of this. Okay, so now let's do another test. Now, what do you think this will give me? Print F percent D new line. Sorry, closing semicolon. Close brackets. Okay. Oh, so something is going wrong now with my code blocks. Let me just close. Let me save and close this and open it back. Save, 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 save. Code block. Open. Oh, we're going to continue from where we stop. Open, 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 open. So whenever you see that stuff in code block, just know that probably it has slight issue or something. So just close it and open it again. Something in Nigerian called slide shoko. Na shoko you don't get. Okay. So now, if you notice what's happened then, so showing me an underscore blink, like the cursor, this stuff that is blinking, so showing me underscore. I didn't expect to see underscore. So whenever I see stuff like that, just close the code blocks and open it again to come back to its senses. Okay, so I was asking you guys to check what do you think will be the output for this. Now look at this now. Now we're dealing with double point. Oh, I'm supposed to semicolon. I mean quotation. Okay, so what do you think will be the output for this now? Yes. Okay, I believe you've gotten your own answer in your mind and you've kept it to your mind. So now let's walk through the answer. Oh, so someone is calling me. Oh, let me just text call me later. Just a minute, please. Okay, I'll send the message. All right, so you've gotten your answer in your mind. All right, so let's move on. Let me explain my answer now, or walk you through the answer. So now looking at this first bracket, this you notice the inner bracket here is just like what we've already done that part here, which is the address of X. Okay, so I don't know if I need to still explain it again. So this what is inside this bracket, that this asterisk Q is already what we've done up here, which it took the address of X. Then now this extra asterisk is where the double pointer comes into play. That means we stop at this place, then do its new work. This one now does its own new work. So it enters inside this address to fish out what is inside is our X. And what is inside is our X is what? It is 6 because it's 5 is already modified. So that means this will print out 6 for us. Okay, so it's not magic. You can see how it's actually simple self. Okay, so you can see how the stages of how it's pointing. So if you point this, let's confirm that to see for ourselves. If it is 6, you can see it still bring the same 6 for us. So this first part, so the purpose of me explaining putting this first pointer just so that you understand how this double pointer moves. So which is the firstly the inner bracket place, which is our asterisk Q. So asterisk Q will enter in to find itself, which is our Q, find itself Q, check what Q holds. So this is the address as expected. Then what is inside that address? What is inside P? One, what is inside P here is address of X. So we get address of X. Then we have another pointer again. So it start from that place where we stop. So we stop at this address of X. Then check again what is inside this address of X, which is 6, not 5. Okay, because we've updated it here. But if we didn't update it here, to take 5. So that's how we got 6 here. All right, so let's do the last part, which is our R, which is the triple pointer. So you just work also the same way, no magic. So I'm going to say, let me comment this. Point F, percent D. I will explain this how just the same way I did for this Q. So I'll break it down the same way. So let me just say percent. I mean asterisk R. So what do you think will be your answer for this one? Okay, 10 seconds. Look at it well and think. 1, 2, 3, 4, 5, 6, 7, 8. This 10-second counting is even slow. 9, 10. Okay, you've gotten your answer in your mind. So let's see if you are correct or you are wrong. So let me walk you through the answer. As usual, again, we focus on the inner bracket parts, right? So as you have the asterisk R. So as usual, the first step is to check for what R is. Check for the variable of R, which is this part where we call the R or declared R. Okay. So now it will check since we have a pointer here. So to enter what is inside this, we have an address. So to enter inside the address to check what is really inside our queue. So enter inside this queue. What is inside our queue is what as our address P. So this is the first pointer move. So we've done the first pointer move, which is this inner brackets. So now we have another pointer, next pointer to do after. So from this place again, to enter inside, what is inside place? We have an address of P. So to enter inside P and check what P is really holding. So when it enters inside P, this is P here. So what is P holding? It's holding the address of X. That means this should print for us also the address of X. Ta-da! If you get it, I'm clapping for you. If you don't get it, don't worry, try again later. Okay? It's not too late to know it. At least now you know it. Okay, so should we print out to test that? Okay, let us test that. So let's just see that quickly. Load. Okay, address. Since it is an address, so I have to change this to P. Okay, so let's print that again. So you can see it's the same thing. Address of X 66. All right. So now let's do the last question. What do you think this will give us? Um, this one will be pointer to a pointer to a pointer. So I think that's one, two, three. Yeah, I think semicolon. So what do you think this one will give us? It's a triple pointer. Sorry. So what do you think this one will give us? 10 seconds again. One, two, three, four, five, six, seven, eight, nine and the half, nine and the quarter, nine and the minute, nine and the everything, 10. Okay, you've gotten your answer. Okay, keep your answer in the back of your mind now. You've got the answer. So let's see if you've got Odo, that's 0, or excellent. So we are going to walk through that same step again. But now it is already easier for us because we've already done this one, and this one is already this one that is inside here. That means we just have only one more move here. Okay, and I think this one will stop at this address of X. So that means this last move here is for us to check what is inside our address of X, which is, well, 5, which 5 is already updated to 6. So this should give us 6 as our final answer. So if you got this as right, you are very correct. That means you are now a pointer genius now. You are a pointer genius. You can scatter ALX now. That's what it means. Okay. So now let me just say something. Now, if this look easy because we are breaking it down this way, you understand? It's what we are breaking down. But if you just get to see this just straight up like this, maybe probably you didn't see something like this at all. No, let me just comment it. So probably you didn't see anything like this. This one never existed. You just see this one on the first go. So just take it step by step. So the first one, we have the asterisk R. This is it here. So we have a pointer, right? So to enter inside the address to get the value. So the value is an address of P. So that's the first movement of this one. So now we have a new pointer. Enter inside this. That means you take this P, go inside the P, check what is inside that P, address of X. Then we have the last pointer. Enter inside that X, check what is inside the X. 6. That's it here. So that's just it. Like, that's it about pointer. So that's your pointer. So you can point to 5 pointer, point to 10 pointer. All is still the same pattern, All right. So pointer will always get the address of the previous pointer. All right. So this one, which is R, stores the address of this. This one, which is Q, stores the address of this. That's why you're seeing this odd stuff like this here. Okay. So I actually have I have one more example to go. But before I do that example, I'd like to take a final question for this part. So just to be sure that everybody is following in this aspect. This person that is joining, the person is just wasting his time. So it's too late. Okay, so let me turn on the microphone for any questions. So any question as regards to this? Okay, coding is fun with oh, coding is fun with you, Lexis. Yeah, it's fun. Thank you. You too. Also, thank you. Yeah, Sikiru. Yeah. Okay, I guess there is no question. Okay, let me just quickly wrap up with the last part so I can quickly drop the video on the group chat. So I won't waste too much time. Yeah. Okay, let me quickly off the microphone to avoid disturbance. All right, so the last part as for this pointers is when it deals with functions and parameters. So this part is one of the tricky part that some of us don't, or most people don't get also. So I believe most of us get this other part we've been doing. But this one now, when it now involve functions coming into play, it may look tricky, but don't worry, it's actually simple. So what to look at functions, parameters with pointers. Okay, so this is what we'll be closing with now. So we erase all of this. We won't need them anymore. Okay, let me just be quick. I want to be quick with this part. So this time around, I'm going to create a, a user-defined function this time around. But before I do that, let me just do this stuff first in the main. That's I'll get like I have a normal integer. I also declare a pointer. Now my pointer holds the address of n, whatever n is storing. Okay. So let's say n is storing a number. Okay, let me say the number is 100. So n is storing 100. Now let's do this. So if I'm to print value, let's check for the value of n before, because I'm going to create I'm going to call a function. So let's the value of n. Let's check the value of n first. So percent d new line. I'll just put n. Have I given the value? Okay, I've given the value 1000, so I'm expecting to see 1000 there. So let's send that point f function address. This time I want to say an address of n. So the address of n, as usual, to get address, you have to use the specifier of %p new line and n for address. Don't forget, use the address operator, which is that and sign. Okay, so we'll get the address of n. Now the same thing I would like to repeat for the pointer aspects. Probably let me just copy and paste this. So copy, paste value of p, address of p. This will be p, address of p. Let me just run this. Okay, 100 value of p. Okay, my value of p should be an address, right? Because so the value of p is the address of n. So that means I'm supposed to put this place as %p, not %d. Let's run this again. Now it looks better. Yeah, so that's the value of p. Our value of p is the address of n. Okay, you can see the address are the same thing. So the address of n and the value of p are the same thing here, as you can see in our output. So address of p, okay, so everything is correct. Everything is correct anyway, so everything is correct. So now I want to do something quite tricky. Now I want to use a function. So let me call the function up here, a user defined function though. So I'll just say modify. I want to modify the value here without me doing the modification here, like without me doing this. You understand? On the norms, I can just do this and I'll modify this n. This n will be 200. So without me doing it here, I want to do it now with a function. So that's just what I want to do. So it's not as if I'm doing something crazy. Okay, so to do that, so let me just create a new variable which I call modify. You can call it anything just so you know. Okay, so I want to modify parameter. So that's just the name of the name of my function now is modify underscore param. And I want to give it a parameter of only one parameter. So just one. And that parameter must be a function, which I just named, I just give it as m. Can be anything, okay? Now, since we have m here, it means we can then print, that means m will have its own value and it will also surely have its own address, right? So just like saying if I put asterisk m is equal to 300 here. So that means I'm able to declare m. Okay, I've already declared the m inside here. So there's no need of me declaring it again. So you can choose to declare it directly inside here, or if you want to do the normal way, you can just do like this and still the same declaration. But since we have pointers, so we can also declare pointers to like this. That means I'm going to get rid of this and to do that, right? But just for explanation purpose, so you won't get confused. There's something I will explain here. So to make more sense, if you get to see this stuff like this, so let me just erase this. Okay. So we have this simply. So now what this will do now, let's assume then, let me jump pack these two together like this just for space. Now, if I call my function, I want to call this function, calling my user defined function below. So if I call the function, if I write modify, then I give it a value of p. Now I'm giving it a value of p because, well, this is a pointer, okay? So a value must also be something related to pointer, which is why, since this p is our pointer, so that's why I represent it as p. So now let me explain what will happen here. Or probably before I explain it, let me just quickly write this printf. So yes, we're going to see the value of what n would be this time around after we've called the function. So the value of n here was the before the call of the function. Okay. So now we've called the function. Now what will happen after the function? That is the new line, the rest after this function. What will take place? What will be our value for n? So percent d new line our n semicolon. So now let me explain what really happened here. So what happened here is that now this m will take the value of this p. Okay, like I said, this can be anything. It can be x. Okay, it can be x. It can be anything. It can be a word. Okay, so x or whatever, it will take the value that p owed. And what is the value that p owed? P owed the address of n. So it means that x is taking n like this. You understand now? So just like the way p is taking this n, so this whole thing is taking, just replacing what this op is still trying to say here. Hope you get now. So that, like, since the calling of the name are the same thing, so we're calling the same function. Okay, so that means these two are like equal to them. So that means x is equal to p. That's what it simply means. Or probably the other one say looks much better in terms of understanding. So maybe I should leave it as x here. So we'll say x is equal to p. So that means I can declare this variable the other way around. So that is x asterisk for the pointers aspects. Okay, so modify parameter, which is the name of the parameter, which I call the parameters, then p will be the same thing as x. So and we know that p holds address of n. So the same thing as x will hold the same address of n. Okay, so now since they are the same thing, that means inside is my x. Now if you notice, I have modified what this my x is doing here by putting that asterisk there. So that means this is now 300. Okay, so that means this update, once the um x enter inside the address of n, it will change what n means. So n will change to 300, no longer this 100 that we are seeing here. Okay, so we've changed it to another function without using our p directly, so using our own user defined function to change something that's inside another main function itself. Right, so if we are to really test this to see for ourselves, we can test that. So let's test this to see if it will print out the value to print out. That means the new value after we have called the function. So let me print this. It's showing an error there. Let me see if I can redeclare different kind of symbol. Oh, I redeclared it 2 times. So what does that mean? Okay, let me see. Let's put the ints here. Let me get rid of this one like this. Let's see this. Let me see the error message. Oh, okay. The same stuff we declared. Oh, okay. It looks as if seems we are stuck with calling it in this way then. Okay, let me see if it will give another error here. It shouldn't now. Okay. Okay, so checking it here now, you can see our value for n before the call is the normal 100, which is the normal 100 here. So now, after we've called that function, it has modified it to 300. So we've modified it through the calling of this function. That means henceforth, whatever you are writing here, like whatever you are coding here, this function has taken place. As if all this one now is like they are dead. Like this n is no longer equal to 100 on its own. It's now 300. So to keep modifying, just be going on and on like that. So that's what it means. So before the calling of this function, it is normal as 100. But when we call this function, it has updated. Okay. It's just a way of doing it alternatively without us getting to do it with our p again. If you want to use the same p again to make it 300, you get. So if you want to use a function to modify it, you can also use a function to modify it by just calling the name of the function and referring it to the parameter with the value of the variable name of where the address is being stored. So that's just it about the whole of function stuff, about storing pointers in the function. So function parameters with pointer, that's just all it is. So I think that's the end of this whole pointer stuff. So I believe we are good to go. Any question for us to close this session? Any last question? Any contributions? Okay, I guess there's no question, there's no contribution. So thank you very much. Thank you for your time. Okay, Esther, yeah, thank you also. Guess you really understand this aspect, so good to know. All right, so seriously, okay, ask your question. This was fun. Okay, ask a question, Freezy. Oh, I can't go back to that one now. Do not see if the example is. You have to go back. Thank God there's a video, so don't worry, you can rewatch it. I will send a link to YouTube. Just rewatch it, okay? All right.